So this question we see there is no graph. So we're going to start right in reading and convert what we read into a picture. So we've got a hockey puck slid along ice in a straight line. So here's our straight line and our hockey puck like this. Straight line. The puck travels at a steady speed of 20 meters per second. So the velocity is 20 meters per second. Now that is the instantaneous velocity, but it's also constant, and it can be treated as the average velocity. Experiences no frictional force, which means it has the steady speed. So that's why it has no frictional force. How far does it travel in 2.5 seconds? So we've got our time here, our velocity here, and we want the distance, delta x. All right, so let's just do this very simply, 2.5 seconds. If we said, well, if it's traveling 20 meters per second, how far would it go in 1 second? Well, in 1 second, it would go 20 meters. But we're talking about 2.5. So if it's going to go for 2.5 seconds, well, it's certainly going to be more than 5. And it's certainly more than 8. It's going to go 20 meters in 1 second. And in 2 seconds, it would go 40 meters. So that's farther than 25. So right away, we see that the answer is 50 meters. We could be that simple with it. But if we were to calculate this, we know we've got an average velocity. Our first approach with every problem is to try to solve it with average velocity. Well, we're looking for delta x, which is the average velocity times the time, which is 20 times 2.5, which, lo and behold, is 50 meters.